So we have these shapes that are called polyhedrons, and we have some examples up at the top. So this is a rectangular prism, this is a square pyramid, and this looks like it's a dodecahedron. So a dodecagon is a 12-sided figure. A dodecahedron is going to be that figure in 3 dimensions. Okay, and then these are not polyhedrons. So this is a cylinder, a cone, a sphere. What do you guys notice about the non-polyhedrons? Yes, they have some kind of curve in them. Okay, and then these are going to have sharp sides. So the cylinder and the cone and the sphere, tying back to what we did the other day where we were naming edges, okay, the non-polyhedron, how many edges do those have? None, right? Okay, so if it's not a polyhedron, then there are no edges. Okay, and then for the polyhedron, this is a rectangular prism, a pyramid, one, two, three, 4, 5, 6, 7, 8, 9, 10. I want to double check and make sure I have the number of sides correct on that before I call it a dodecahedron. Okay, so this one has edges. Okay, so polyhedrons are going to be formed by 4 or more polygons that intersect at only their edges. Okay, so it makes sense that these do not, that these are not polyhedrons because they do not have edges. So what we have is this formula called Euler's formula. Euler was a mathematician that influenced many geometric properties. He wrote a full book on it. And the formula that he came up with is for any polyhedron with V vertices, E edges, and F faces, you could do the number of vertices minus the number of edges, add the number of faces, and you would get 2. Okay, so the V stands for the number of vertices, E is the number of edges, and F is the number of faces. And if you subtract vertice minus edge and then add the number of faces, you will get 2. Okay, and remember the faces are all of the flat surfaces. So let's use Euler's formula in example 1. And when we do that, we're going to find the number of vertices, edges, and faces of each polyhedron. And then we're going to verify Euler's formula. So when we verify that, what we're going to be doing is plugging in those values and then making sure that they work. Okay, so I'm going to give you a minute right now to find the number of vertices, edges, and faces. Okay, so write down what those are for the vertices, the edges, the faces. Okay, so Sam, how many vertices did you get for part A?
12.
12. Do you guys agree?
Yeah.
Okay. Sarah, how many edges did you find? 18. All right. And then Logan, how many faces? 8. Right. How did you guys do at finding those? You okay? Remember we did that in 10-2. So the vertices, you're just counting. 1, 2, 3, 4, 5, 6. There's 6 on top, 6 on the bottom that make 12. The edges, you're going to have 6 on top, 6 on the bottom, and then you're also going to have the 6 that connect them together, which is how you get the 18. And then the faces, because this is 6-sided, there's 6 faces around, and then the 7 and 8 come from the bases. So we're going to verify using Euler's formula. So if I plug in 12 for V, 18 for E, and 8 for F, what I should get is 2. So I did 12 minus 18 first to get negative 6. Negative 6 plus 8 is equal to 2. So 2 equals 2, and then we verified it. Okay, so when you're verifying, you're basically just going through the steps showing that you do get 2 on the right side and the left side. Okay, and then we're going to do something similar for B. So if you haven't already, I know some of you have. Will you guys find the vertices, the edges, and the faces for So the important part of the verifying is showing that you understand that both sides are equal. For B, Ethan, how many vertices did you get? 5. All right, good. Baron, what'd you get for the edges? 8. Good. And then Jana, what'd you get for the faces? 5. All right, so now when you're verifying, okay, I see a lot of us just putting this down, the 5 minus 8 plus 5. Okay, that's not all there is to verifying. You have to make sure that you're showing me that this is going to be equal to 2. Okay, so 5 minus 8, you could do that part first. I did 5 plus 5 since I knew that was going to be 10. So 10 minus 8 is going to be 2, and then 2 equals 2. So it is important that you're showing that 2 is equal to 2, okay, as part of your verification. All right, and then let's go to page 2. Okay, and for page 2, what we're going to look at is the diagonal of a right rectangular prism. Now with a diagonal is going to connect 2 vertices of 2 different faces. Okay, so remember this is a 3D shape. Okay, so the diagonal is going to connect 2 vertices of 2 different faces. The length of a diagonal is going to be equal to the square root of the length squared plus the width squared plus the height squared. Where do you guys think this formula comes from? Yeah, the distance formula. It's really similar to the distance formula. It's just usually with the distance formula, we were in 2 dimensions, and now we're going to expand it to 3 dimensions. Okay, so we're going to to find the unknown dimension in each figure. So it tells us that the length of the diagonal of a 6 centimeter by 8 centimeter by 10 centimeter rectangular prism, we want to understand what the unknown dimension is. Okay, so the dimension that we're trying to find is the length. Of that diagonal. And if it's a 6 by 8 by 10, 6 is going to represent the length, 8 is going to represent the width, and 10 is going to represent the height. So now I'm going to use my equation to find the diagonal of a right rectangular prism. And I'm going to substitute. Now, a lot of this we can actually do in our head, because what's 6 squared? 36. 8 squared? 64. 10 squared? 100. So what happens when you add 36 and 64? It's 100, right? Okay, so we have the square root of 200. Okay, and then let's write this in simplified radical form. What's the perfect square in 200? 100, because it's 100 times 2, right? What's the square root of 100? 10, so then it would be 10 root 2. Okay, and that is going to end up being about 14.1 centimeters. Okay, make sure you know how to find that in both ways. So whether it tells you simplified radical form or whether it tells you round to the nearest hundredth. Okay, and then on the next page, we're going to look at the distance and the midpoint formulas in 3 dimensions. So we've already done the distance and the midpoint in 2 dimensions. Now we are going to expand that to 3 dimensions. So first, let's just look at the picture for a second. You have your M here, your midpoint. Your midpoint is going to be the point that's halfway in between. And then the distance formula is going to be to find the length of that segment. Okay, so the distance formula in 3 dimensions is the same as it is in 2 dimensions, except now, instead of just having x and y, what else do we have? Z. Okay, and when you're in 3 dimensions, you have the x-axis, the y-axis, the z-axis. That's where that z is coming in. The midpoint, again, has the x sub 1 plus x sub 2 divided by 2. Same thing with the y. The only thing additional that we have is now the z. Okay, so a couple new things that we're introducing, and that's the space. So the space is the set of all points in 3 dimensions. And then, like I said, now there's going to be a z-axis. If you have a 3D graphing system, you have x and y, and then you have z as your vertical axis. And then I just said, recall that in 2 dimensions, this was our distance formula and this was our midpoint formula. So looking at the original, comparing it to the new one in 3 dimensions, you can see the only thing that we are now adding to that is the z coordinate. you guys get to pre-calc, you'll do some more with that three-dimensional system. This year in pre-calc, we did some graphing in 3 dimensions, and then you'll incorporate some vectors. All right, you guys ready for the last page? Okay, and if you are ready to go on to the next page, you could probably even do this yourself without me, because you are just applying those 2 formulas. All right, so if we're gonna find the distance, the first thing I do is I label my points so I know what I'm gonna plug in for my x1, y1, z1. So notice that all of them in the first one are gonna have sub 1. All of them in the second point are gonna be sub 2. Okay, so now what we're gonna do is plug that in to our equation for the distance formula. So I'm going to give you a second to do that. And then when you're done, go ahead and check with your elbow partner. See if you guys got the same thing. Okay, so let's see how we did with the first one. So when you're subtracting, you'll end up getting 2 squared, 8 squared, and 5 squared. Okay, which will give you the square root of 93. Okay, and then it says round to the nearest tenth if necessary. Okay, so then it would be 9.6 for the distance. How'd that go? Good? All right, and then the next thing we're going to do is the midpoint. Really, the midpoint is just the average of all your points, because you're adding them and then dividing them by 2. So because these are all 0, right, all you're doing is taking these and doing what? Dividing them by 2. So what's 2 divided by 2? 1. 8 divided by 2? 4. 5 divided by 2? 2.5. And you can either, you could leave it as 5 over 2, or you could leave it as 2.5. All right, so your homework is the 10.3 worksheet that I am going to pass out to you now.